Okay, let's look at this grade 10 question. It's a past paper question from November 2015 with stoichiometry calculations. If you look on the side here, we have the formulas from the formula sheet and we have some things from the periodic table. And so you will need your periodic table and your formula sheet if you don't know the formulas. Okay, so it says to you, hydrogen and nitrogen react to form ammonia. The reaction that takes place is represented by the following equation. Okay, and this equation is balanced. You should always check your equations are balanced before you start. It says define the term 1 mole. So 1 mole is the amount of substance having the same number of particles as there are atoms in 12 grams of carbon-12. Now it says to you, how many moles of ammonia will be produced from 1 mole of hydrogen gas? So here we're going to use Avogadro's law, okay? And if we look at the equation, if we look at the mole ratio, if you have a look there, hydrogen reacts to form ammonia, and if we look at the coefficients from the balanced equation, there are 3 hydrogens producing 2 ammonias. So if you only had 1 mole of hydrogen gas, you are going to divide both of these by 3. So 2 divided by 3, it will be 2/3 moles. Because can you see mathematically, to get from 3 to 1, we must divide by 3. So if we do it on this side, we must do it on the other side. So you will only end up with 2/3 of a mole of ammonia. Now this 9.1.3, this question is only 4 marks, but before you get carried away with the question, you have to be quite careful. It says to you, initially, there are 10 cubic centimeters of nitrogen, okay, and then there are 24 cubic centimeters of hydrogen. So that's fine. If you look at our equation, the reactants are nitrogen and hydrogen, but the problem is if you look at the mole ratio for this equation, okay, and now we're looking, because we're looking at the reactants, we're looking at the nitrogen and the hydrogen, okay. From the balanced equation, the coefficients are 1 and 3. So we know, because of Avogadro's law, if we had 10 cubic centimeters of nitrogen, we would actually need 30 cubic centimeters of hydrogen. But if you have a look here, we don't actually have 30 cubic centimeters of hydrogen. We've only got 24 cubic centimeters of hydrogen. That means we've actually got too much nitrogen, okay? So if there's too much nitrogen, we say nitrogen is in excess, okay? So if nitrogen is in excess, we call the hydrogen is the limiting reagent, okay? So now what is controlling this reaction? The hydrogen is controlling this reaction, because the moment all the hydrogen is all used up, the extra nitrogen is just going to sit there. So if you then had a look and you have 24 cubic centimeters of hydrogen, we're still looking at this mole ratio here, 24 cubic centimeters of hydrogen, it's 3 times as much as the nitrogen. It would only need 8 cubic centimeters of nitrogen. So the moment all of my 24 cubic centimeters of hydrogen are used up, I will only have used 8 cubic centimeters of nitrogen. So the amount of nitrogen left, okay, is 10 minus 8, which is 2 cubic centimeters. So remember what's going to happen here is we're going to mix the nitrogen and we're going to add the hydrogen, and they will then react to form ammonia, okay. So we mixed 10 of these and we mixed 24 of these. So now we need to figure out how much ammonia we made, okay? So some of this is going to be left over. We've already realized we're going to have 2 cubic centimeters left over. But how much ammonia are we going to make? To figure out how much ammonia we're going to make, we have to now look at the mole ratio again. We have to look at the mole ratio of what is controlling this reaction, and we decided what is controlling the reaction is the hydrogen. So if the hydrogen is in charge because there's not enough of it, we need to look at the hydrogen's relationship with the ammonia, because you can only make as much ammonia as you have hydrogen. So these are in the ratio of 3:2. So if we've got 24 hydrogens, okay, then if we have a look here, 3 times 8 is 24. So this must be 2 times 8, which is 16 ammonia. So we're going to make 16 cubic centimeters of ammonia, okay, and that means all the hydrogen has been transformed into ammonia, and 8 cubic centimeters of the nitrogen has been transformed, and we are left with 2 cubic centimeters of nitrogen in excess. So altogether there will be 18 cubic centimeters of gas in the container, because all the hydrogen got used up, and then 8 cubic centimeters of the nitrogen was used up. And if we worked out 16 ammonia, 16 plus 2 gives you the 18 cubic centimeters left in the container. Now it says to you, in another experiment, 80 grams of hydrogen reacts with nitrogen gas to form ammonia. Calculate the number of moles of hydrogen gas reacted. So now we've got a mass here. Can you see a mass? Okay, and we want to find the moles. So we're going to use this formula over here, N equals M over M. So for 9.1.4, we're going to say the number of moles of hydrogen is going to be equal to the mass over the molar mass. So it's going to be 80 over, what is the molar mass of hydrogen? Well, on the periodic table, hydrogen weighs 1, but it's a diatomic molecule. So it's going to be 1 plus 1 is 2. So we will then have 40 moles of hydrogen gas reacted. So if this reaction is complete, the next part says calculate the volume of nitrogen gas used. So now we need to look at the mole ratio. Okay, so if we know how much hydrogen we used, we can predict from the balanced equation how much nitrogen we're going to need. So if we have a look here, the mole ratio from the coefficients of the balanced equation, nitrogen to hydrogen, is 1 mole of nitrogen to 3 moles of hydrogen. So we are then going to say we had 40 moles of hydrogen, which means we've got 40 divided by 3 moles of nitrogen. Okay, we don't need to just work that out yet. You can work it out and get a number, but for now we want the volume of gas used. So if we want the volume of gas used and they say STP, we know we can use the molar gas volume and this formula because this is a gas. So we're going to say the number of moles of nitrogen is equal to the volume of nitrogen over the molar gas volume, which is from the data sheet 22,4. So V over 22,4 is going to be equal to this value for the nitrogen we got here, which was 40 over 3. So if you plug that into your calculator, you will end up with, I can't remember, something like 298,67, and this is a volume, so we measure it in cubic decimeters. So you will end up with 298,67 cubic decimeters of the nitrogen being used. Okay, so now I want to do this part 9.2, but I've run out of space, so I'm just going to rub everything out. So if you want to copy a calculation, pause the video and write it down now. Okay, now let's have a look. And it says to you, when 207 grams of lead combines with oxygen, 239 grams of a certain oxide of lead is formed. Now lead can have a varying valency, so it can be PB304, PBO2, you don't know. So it says to you, use a calculation to determine the formula of this oxide of lead. So they want you to figure out what is the empirical formula or the chemical formula for this lead oxide on this side over here. So we're going to use the law of conservation of mass here. It says to you, you had 207 grams of lead. They don't tell you how much oxygen, but you ended up with 239 grams of the oxide. Okay, so how much did my oxygen weigh? By the law of conservation of mass, the mass on the left must equal the mass on the right. So the mass of the oxygen is going to be 239 minus 207, which is 32 grams. So 32 grams of oxygen were used in this reaction. Now it says, use a calculation to determine the formula of this oxide of lead. So if you have to do this, you always have to find the moles. So to find the number of moles of lead, okay, we are given a mass. So we're going to use the formula mass over molar mass, N equals M over M. And it's going to be 207 grams, which is what we weighed. And then if you go to your periodic table, can you see over here I've taken out lead from the periodic table. Lead actually weighs 207, so the number of moles of lead is going to be 1. Now you have to find the number of moles of oxygen. And now we're not looking for this diatomic oxygen that's a reactant. We are actually looking for the oxygen here that's as an oxide that is bound to the lead. So we want to look at oxygen atoms, not oxygen molecules, okay? So if we want to figure out how many oxygen atoms we've got, we take this mass of oxygen that we found, which is 32 grams, okay? And we put it over the mass of one atom, and the mass of one atom is 16. So 32 divided by 16 is 2. So if you have a look there, what is the ratio of my lead atoms to my oxygen atoms? It is 1 is to 2. So then it asks you, what is the formula? So the formula will be PB, and I don't write the 1, it's an invisible 1. And then I've got 2 oxygens, it will be PbO2, and that will be the formula.